Thanks everybody for the invite. As I said, when a few people joined, I joined this group, I think maybe not quite 2 years ago, and I had the privilege to present at the normal conference as a panel member and talked a bit about Philips on this journey. And I had promised to come back and give an update specifically on the machine learning aspect of our planning at Philips. So I'm an American, currently living in Amsterdam. I've been here about almost 6 years now. I'm classically trained in microbiology, so a non-traditional finance background. I did go back to school and get an MBA after working in cost accounting for a few years. And really, most of my entire career has been in corporate FP&A and primarily at Philips, also with a large winery group in the U.S., but primarily at Philips for what we'll talk about. I'm not a data scientist. I know I'm maybe an FP&A data scientist, but I'm not a data scientist. I'm not a BW programmer. I'm not a SQL developer, but I am happy to be the head of a very technical IT team that spreads about across 3 countries and currently is about 100 FTEs if you consider the FP&A team and the IT support underneath it. And I'm here to talk to you about the forecast of the future, which I'm the global technical lead for. So a bit of fun thing. So I equate viruses and enzyme structures to data models. So that brain of being a microbiologist and a data scientist makes a lot of sense to me. And I do lead 4 sort of specific groups within Philips. So I have a SAP Business Warehouse applications where we do a lot of the internal reporting for our business market structures, and that's where a lot of the data comes from for the machine learning. I also manage the team that uses SAP BPC for our enterprise planning. I have a large team that does digital dashboards. We have a mix of Power BI and Click. And then I also lead the data science community within the FP&A team, and that's and it really takes a combination of the 4 teams to make what we're working on at Philips really come together. So that's a bit of background about myself. I'd like to talk through a few areas, just a quick introduction to how Philips products lines are, because it'll make a bit more sense when I get into the details. I want to talk a little bit about our journey to create a digital P&L. And one of the components of that is machine learning as an input to our digital planning. I'll walk you through a little bit about the architecture of how we've put the machine learning together. And then really we have sort of a 2.5, 3-year plan. So I want to talk about what's the short-term objective, what's the long-term objective, and then we can take questions at the end. I'm also okay to take any clarifying questions along the way if there's something that's just not doesn't make sense. I'm happy to try to answer those questions as we go. So those that aren't familiar with Philips, we have a variety of product lines or divisions. We make things like Sonicare toothbrushes. We make electric razors. We make sleep and respiratory masks. But then we also have a large variety of hospital equipment, so CT scanners, MR machines, ultrasound machines, and also the software that helps radiologists and doctors bring those images together into the central IT systems. And then we also have a large group that works as a service engineers that actually go out and service those machines to keep them running. So we have a very diverse product line. And you can see sort of the bar in the middle, that's really the complexity of planning. So the things that we consider sort of boxes, toothbrushes, razors, those are actually quite easy to use planning functionality, just straight adders and run rates and those types of things that are driven off of the sales values. But when we get to the right-hand side where we start talking about large hospital equipment, timing of deliveries, and then service, our planning becomes more complex because of timing of delivery, unknown service events, and those types of things. So the other reason I wanted to share this journey with you folks is because the last couple I've been able to attend, I haven't been able to attend all the sessions, but the 2 I did attend were mostly around predicting the sales information. And we've at Philips have made a distinction that as FP&A, we want to take the trusted sales plan coming up from our S&OP team, so outside of finance, and then we want to take that trusted sales plan and then create a cost of sales plan around that to fill out the P&L. So where we're using machine learning is actually to predict cost based on those sales. So a slightly different use case than what the last couple have talked about. So again, if we start at the top of the wheel, again, we are looking at our supply chain to provide that one sales plan. We currently plan to the end of the current year, but one of the forecasts of the future principles is that we do want to extend our planning horizon out to 18 to 24 months. The other principle we have is short term, medium term, long term. So any data point that we can touch and feel that's underpinned, we like to use that in our short-term planning, because then we can also use that data to explain our variances during our month-end analysis. So if I go back to the previous picture where we talk about big hospital equipment, we actually have a pretty comprehensive order book where we have those customer commitments in the order book, and as many of those orders that we want to use that for underpinning our financial plan. Now, however, if we talk about the service organization, those events, we have pretty consistent and reliable revenue, but the cost is very unpredictable based on service events. So that's really where we're trying to use the machine learning algorithm to then predict the costs. We also have a comprehensive FTE and cost center planning, so we're trying to also use that actual data again to fill this digital P&L. We also have other applications for advertising and promotion, R&D, those types of systems that we're simply copying the data into this digital P&L. And then, of course, any good planning process needs to rely on the human factor, the people in the markets and business making those final decisions to own the numbers. So what I want to focus on today is we're trying to create a comprehensive digital plan, and then we want to try to inject machine learning where it makes the most sense in those intersections. And I'll go into those specifics in a minute. So if I sort of show you our P&L, and I talked a bit about products being the toothbrushes, we've got equipment, which is the big equipment, and then we've got software and services. This is how we're attempting to then use these digital drivers to then create a digital plan. So you can see along the top that we rely on the S&OP process to give us our sales information, and then we've identified a variety of ways to pre-fill the cost of sales. And you can see here we've got a mix of margin analytics, machine learning, and adders. And these are all ways that once we have those sales information coming in, we can actually run digital tooling to then use those information to then backfill the planning system. So our idea is that we want to be able to open the system pre-filled and then make corrections. So again, on the short term, we want to use things like margin analytics, which is where we have all of our equipment underpinned orders. So we feel like those give us the best actual underpinned cost of sales. So we want to use that information and simply put it into the system. But then for software and services, we feel like we don't have a good way to predict those costs. So we do want to use machine learning. And then if we look out into the future, we feel as an organization, the further you get out into the planning process, the more people are really sort of guessing what the outcome is. And we want to prove through machine learning that algorithms can predict just as accurately as our financial colleagues, and then we can take that burden off of them. So we're looking at machine learning in a variety of places. In the chart below, you can see the percentage of sales breakdown. Let me see if I can hide this little guy. Sorry for that. So you can see that if we look at our, basically our business market combination, 75% of our cost of sales of our total cost base actually sits in this area. And you can see that we've actually used for the service component, which is the box in green, so about 17% of our cost of sales, we've actually implemented through machine learning. And that's a bit what I want to explain how we went we went about that, and also what we have in store for the future. So we started this journey about a year ago, and for the second forecast in a row, we've successfully preloaded all of our market cost of sales for our service organization through an AI ML pre-fill of predictions. So I want to explain how we did that a bit further. We have three different AI models that we have at Philips. One of them is in our sales S&OP organization, and again, that's outside of finance. We're highly connected with that team because we need that as our primary input, and they're using basic time series calculations to look at their pre-fill for their sales information. We're also trying to overlay things like new product introduction schedules and also our market share, market growth to enrich those machine learning. But that's one place that we're using in the overall process. The second one is what I've talked about, which is what I'm focusing on today, which is our service component. The drivers that we see there are really we see a high correlation of using just the sales to predict the cost, but we also have other factors like our equipment order intake, our equipment sales actually then drive some of the cost base because of the way that we use our engineers to do some of that work. So we've been experimenting with which drivers actually make the most correlation to the results. The other thing that we're in is actually an FTE, so our head count per country is also a highly effective driver for predictions. Even if you don't have grade or salary or other costs, just simply putting in a count per country is enough to then drive an accuracy improvement in our algorithms. The last place that we're using machine learning is we're actually trying to predict the entire P&L for Philips, and we want to do that for the outer quarters. And there, because we're looking at more of the company information, we were looking at drivers in addition to the ones I've talked about. We're also looking at inflation rates per country. We're looking at shipping container costs. We're looking at cost of helium. So cost of helium is a big driver in some of our MR machines. So we're looking at experimenting with these macroeconomic factors to actually create inputs then for our machine learning to predict the future costs. So I want to deep dive a bit on how we're using the current data we have to then run our machine learning models. So the approach we've taken is that we want to take you can see here in the blue box. So each of these components is our previous financial forecast, and we've used those financial forecasts to be also our training, but then also our predictions. So we've gone back 2 years and taken each of our forecasts and used those in our algorithms to train the models, but then also to predict. And then as we move forward with each of those forecasts, we've actually captured the accuracy of the predictions, made that available to the teams to see how our historical predictions would have worked against the information that they presented. And then we can have a fact-based discussion about how accurate the machine learning is against the business planning. And then obviously when we get to the last part of the process, we take the future predicted sales, and then we can predict with the other algorithms then what our future predictions are going to be. So we use our existing information to then train the model, publish the results to the team, and then evaluate how to improve it from there. So get into maybe some of the deeper machine learning. So we've actually, and I'll get into the architecture in a minute, but we actually use an Azure data lake to actually do a lot of these calculations. And we've been able to split these training runs into 3 distinct tests, and then using the AI capabilities of the Azure data and other things, we've actually been able to then run on average about 17 models per run, and then we actually allow the machine learning algorithm to pick the best results of the 17 models to then reduce the error function. So we use the technology to run the training, to pick the best output, and then consolidate that into one final answer. Yeah, again, we're trying to fit it to the we're trying to fit the answer to minimize the loss. We have a few different ways to do that, to apply to the data. The last thing we do is, again, we try to tune the data and use the technology to again figure out the best models. We have a combination of random forests, time series, those types of things. But again, we let the systems pick the best solution, and then publish that to the results. Now, when we publish those results, the way that we make it available to the users is we actually take the historical information, so the published actuals, the published forecasts, and our predictions, and we make that available in a Power BI model, and we show them what the actuals were, what the business plan was, what the predictions were across markets, businesses, and also planning items. And then we can have a fact-based discussion about which intersections are working, which ones are not, and then we can deep dive into those information based on local knowledge, to then fine-tune the models. Once we have the onboarding of the markets, we can run this process with the available sales we have. We can do the review, and then we also provide an output table, which can then be used directly in the system, and we automatically fill that back into the planning system at the end. If I were to show you a bit about what that looks like, so I've taken one of our business lines, and I've hidden some of the data just to not show the values, because I don't think it's the total part of the story, right? But we're able to look across our different market groups, and again, we would have our sales actuals, our cost actuals, and then what the references were, and we can actually show them what our, in this case, IGM percentage was across the different markets. So I've highlighted a few that are green and yellow. So green is obviously better, and then yellow is slightly worse to worse. So I think the other learning is it doesn't have to be perfect or better in all cases. I think a lot of the success you have is being able to predict at the same level of accuracy that the business process works, because then you can take that time out of the organization. So you can see here some pockets of excellence. North America is always our largest market, no matter which business line. So the fact that we're almost 4 points better is a pretty big accomplishment. And then some of our smaller markets, we can live with these slight deviations. And then you can see overall that we're at almost a 1.6% IGM prediction, more accurate than the business. And then if we do the same view split by month and quarters, then you can also see that there is some fluctuation, really based on the business activity. So you'll see that certain months can be better or worse, but then the quarters are also better or worse. But in general, the overall trend is consistently better across the planning for this particular service component. So if I talk a bit about the architecture, so we typically, if we start to the left, on the left-hand side here, so we get the S&OP information through their tooling. We ingest that into our SA Business Warehouse. There we have logic where we take the S&OP data, and we have to do a bit of logic to split it into our final market structures. We take that sales data then and some of the other drivers that I mentioned, and we can automatically feed it into our Azure Data Lake. And then we run it through a series of Databricks algorithms that read into these machine learning models. And you can see here again that we run about 17,000 models. And then it itself picks the best results per the models. And then we can feed those into the final Power BI report, or send them along an automated chain back to our business warehouse that then is put into our BPC system. And we can run this entire pipeline we can run this entire pipeline in 2 to 3 hours from the time that we get to sales until the time that we pre-fill it back to our BPC system. So, this is an example where, you don't have to go out and buy a planning tool that has built-in AI. If you have planning tools and you have, desktop machines or access to a data science platform, you can actually then still use the machine learning and still put it back into your current system. So that's the one sort of decision we made. We chose not to, go out and look for a different planning system. We said, let's take the information we have and figure out how to pre-fill it back to our existing planning systems. And in this case, Azure Databricks and the Azure data gave us the right technology at the company then to do that work. And I don't think that it matters that it's Azure or AWS or Google. I think a lot of these warehouses do the same types of things. That's what you have available at your company, and making sure that your teams have the right skill set to operate the tools. I think that's the most important thing. In the previous presentation, I talked a bit about how we resource. In our case, we hired the resources to fit the technology. So we already had the Azure platform. So we purposely went out and hired our data scientists that had a finance background, but also know how to use the Azure data lake technology. So I think it's important that you fit your resources with the technology. And in some cases, in our case, we hired the technology into the system. Find my cursor here. So as I mentioned in the beginning, right, we're trying to create this digital P&L, and machine learning then is just one component. So when we take the output of the last slide and we have the machine learning outputs, then we also digitally connect the other tools that I talked about. So we connect the A&P tool, we connect our cost center planning, we preload the equipment data from the margin analytics, and we can put that all together then in our enterprise planning system. So we call this the data grid. So we take the best available information per KPI, we gather that all in this case a BW system, and then make that available in our planning system. Therefore, we can use the technology to do the heavy lifting, do the first iteration of planning, and then open up the system for final market and business review enrichments to then finalize the platform. That's the idea of this digital P&L. If I take this one step further, then, so what I've described is really the left-hand side. So over the short term, we want to use the best available underpinned information we have. Again, that's trusted sales from supply chain. That's our detailed order book, a mix of AI for the service component, cost center planning, and then connecting our other planning systems, making our responsible business and market leaders sign off and do those finals enrichments to then create that P&L. We want to do that with a decentral team. So that means each market and business has people that make those final decisions. We have the lowest level of granularity. So we have product detail, country detail, sort of 17 buckets of planning in our cost of sales. But again, we want to then also make our forecast extend out to 18 months. And in there, we feel like anything after a certain period of time, in this visual, we've said anything after 6 months, we really feel like we can take, if we have a trusted sales number, we've proven that a machine learning algorithm can predict better and faster and quicker than our business roll up, take some of the bias out of the information, and then we want to make that a more aggregated results, and then make it more touchless. So we actually don't want the business and markets to make any corrections to that. We would do that with a smaller central team to ensure that we don't have any bias creeping into the outer quarters. And again, I try to describe that then our drivers for the longer term period and the full Philips results then need to be different drivers. So then we go back to, market share, we go back to inflation, procurement, type bill of material factors in the world, and then still rely on our strategic planning and our business strategy to then come up with those drivers for the future growth of the company. We're not there yet with the mid to long term, and so I'll talk a little bit about, we're kind of right in the middle of the chart here. So if I were to sort of summarize as kind of the journey we went on, we started a couple years ago. We had a BPC system. We were using it primarily as a data collector or a database. And so the first thing we decided to do is let's connect the dots and let's start adding the cost center planning, the A&P tool, the order book details, and just trying to make the data that we have fill the system faster. We then said, let's try to standardize the calendar. So the other thing we're doing is we're trying to convert from a monthly latest view that's mostly offline, and then we do a quarterly forecast. We're trying to increase the frequency where we will do this digital planning every month, and then have a digital latest view and a digital outlook being the same thing. Once we perfect that change in the process through the second half of this year, then we would look to extend the time horizon to the 18 to 24 months, and then make that repeatable every month to give our business outlook much more consistency and a long-term view. And then obviously along the way, we want to fine-tune the model. So, I think an important message here is you don't have to do a big bang. You don't have to make it a revolutionary part of your process. That if you find the pockets where machine learning fits in systematically into your planning process, that's already, I think, a great place to start to learn how it works. If I were to sort of summarize the lessons learned or recommendations for people that are maybe at the beginning or haven't started yet, I think it's important to have an executive sponsor, someone that's trying to drive the change in the organization. It's also important to have an early adopter of the technology. So in our case, we had a head of finance for one of our market groups that was a strong advocate of using digital tooling, including machine learning, and he took it upon his team to be the first adopter. We were highly successful in that first market, and that made us easier then to expand it to the other markets. So I think that is I think one of the critical enablers for our team is we did find a strong advocate from the beginning that really pushed it through and made it work with his team and improved the technology. Also leads to the second one, which is sort of start small but dream big, right? I think you do have to have a big dream and a big endpoint, but you don't have to get there in one go, right? So find that adopter, find a pain point for them, and start small and prove the technology. Make sure you have the people and the tooling to do what you want. I think that's critical. I think the other success of my team is that we have, we're not hardcore finance people, but we're not also hardcore IT people. So finding data savvy people and your experts in your planning and systems is a great way to start building out, either a small planning team or a small technology team. That way you can have business discussions and IT discussions with the same folks. That's been one of the successes of our team. I am a strong advocate of hiring data science capabilities. So really hardcore data scientists, I think, is important, and obviously having a finance background is important. So having somebody that's worked on some sort of finance machine learning, I think, is important just to then have those discussions with the business. I don't recommend training financial analysts to be your hardcore data scientists. That they do have a role to play as you build out we call them citizen data scientists. I'm not sure what others call them, right? But the people that need to understand the data scientists to give the input, but don't necessarily need to program everything, you do need some of those. But the people that are programming and need to do the algorithms, you really do need strong data science professionals there. The other thing we chose to do is to separate our machine learning from our standard process team. Not really to have a competition, although there was an idea that we need to prove that our algorithms are better. But you don't want to distract from everyone else doing their jobs as you begin, right? So in our case, we let the normal organization run the current process, and we worked with that small team from the early adopter market to really focus on an alternate process and then roll that out. So I think that was also a success from our side. You have to involve the businesses and the local experts. So I think there was a question on what's the local FP&A role. I think it's really, they know what happens in their markets, local knowledge, trumps technology in every case. So you do need to have those discussions with the business. You do need to spend significant time to discuss the results, the outliers, what happened here to drive this variance. If it's something that we can code into the models, you want that feedback loop to make sure that you can bring it back together for the next iteration. And in our case, there was significant pushback from the teams that weren't in the early adopters. So do expect some level of pushback and buy-in from the organization. It is especially with finance folks, if they can't touch it and see it and you can't explain exactly what it does, then trying to explain a machine learning algorithm about what's going to happen in 6 months is sometimes a difficult conversation. So that's maybe maybe not a recommendation, but a lookout, right? Make sure you're prepared to have those conversations. And then the last point is really, again, I don't think you need to buy new planning software. If you have a system that you trust and are able to use technology to fill from other data sources, then in our case, we decided to keep our current system and feed in the machine learning from the data lake into the BPC tool. We did look at other tools that had built-in algorithms. We chose not to buy another planning system from a cost and a sort of a sunk cost of what we had spent to put BPC in. So you can go the route of fresh technology. That there's lots of good tools that have built-in machine learning algorithms, but I don't think that's the only way to accomplish making a first step using machine learning into the planning process. So there's probably other examples where you need to, but in our case, we sort of retrofitted the systems.